Today's lesson has two lesson objectives. Our first lesson objective is that students will identify parallel and skew lines. So in order for lines to be considered parallel, they have to be coplanar and they do not intersect. So if you look at the figure at the right here, I've got two lines, they're in the same plane. They're not going to intersect, and how that's usually denoted is with a couple of arrows on the lines to show that they are parallel. Skew lines are non-coplanar, and they also do not intersect. So if you look at this figure with the box, I can see line F here is skew to line A down here on the bottom. They're not in the same plane, but they're never going to intersect either, and so they are skew lines. Parallel planes are exactly what they sound like. They're planes that do not intersect. So using the same figure on the bottom here, plane ABC is parallel to plane EFG. So those are parallel planes. All right, and a transversal is a line that intersects two or more coplanar lines at different points. A line that intersects two or more coplanar lines at different points. So in my figure here, I've got three lines, kind of random there. My transversal would be the pink line that I just drew, because it intersects those three lines in three different points. Here, here, and here. So for example 1, we want to be able to identify relationships in space. We want to be able to tell if lines and planes are parallel or skew. And so A tells us to find lines, or a line or lines that are parallel to AF and contain point E. So if I highlight AF here, I want a line that is parallel to that and goes through point E. And so I can see that that would be this line here. So line EJ would be parallel to AF containing point E. And if I want to know a line that's skew to AF and contains point E, let me erase this one. There's a number of lines I could choose for that. Nope, actually, there's only one line I can choose for that. And that, because it has to go through point E. And so that would be line ED. All right. Then they want me to find a line that is perpendicular to AF and contains point E. And so perpendicular would be right here. This should be marked as a right angle up there. But, so line AE would be perpendicular to line AF. And then finally, they want to know a plane or planes that are parallel to plane FGH. Oh, that reminds me. This is supposed to be an H back here. So plane FGH is this plane at the back. And a plane that would be parallel and contains point E would be the plane here out in front. So plane ABC. The parallel postulate states that if there is a line and a point not on the line, then there is exactly one line through the point parallel to the given line. If a line and a point not on the line, if there's a line and a point not on the line, then there is exactly one line through the point parallel to the given line. And again, just a little reminder, those arrows mean that the lines are parallel. The perpendicular postulate is very similar. It states that if there is a line and a point not on the line, then there is also exactly one line through the point perpendicular to the given line. And we've already seen this before, but just a reminder, when we're talking about perpendicular, we use that symbol in upside down T. And then for parallel, I should have mentioned up here, we use two lines close together to indicate parallel. So for example 2, we're going to identify parallel and perpendicular lines in the figure that's given. So part A says name a pair of parallel lines. Well, there's only one set of lines that are marked parallel, and so those are the ones that are parallel. We can't assume anything else. So line AB is parallel to line CD. And as far as our perpendicular lines go, we've got a right angle marked right there. And so because we've got that right angle marked, I know that line AB is perpendicular to line AC. So part C says, is AB perpendicular to BC? Well, of course, you can't assume anything by the picture just because it looks like they aren't perpendicular. We can't necessarily say that that's the reason they aren't. But we can say that they're not perpendicular because only one line that goes to AB through point C can be perpendicular, and we already said AC was the one that was perpendicular to it. So the answer is no. There can be only one line that's perpendicular to AB through point C. So because AC and AB were perpendicular, there's no way that BC could also be perpendicular to it. All right, so our second lesson objective is that students will identify angle pairs formed by lines and a transversal. So when lines are cut by a transversal, we have four types of special angle pairs. The first type of special angle pairs is corresponding angles. And corresponding angles are simply angles that are in corresponding positions. So T is my transversal here. So I'll go ahead and mark that. That's my transversal. And angles that are in corresponding positions. So what I mean by that is, for instance, angle 1 is above line M and to the left of the transversal. And if I look at the other line, angle 5 is also above the line and to the left of the transversal. So they are in corresponding positions. Angle 1 and angle 5 are corresponding angles. And the same is true of 2 and 6. They are both to the right of the transversal and above their corresponding lines. And so angle 2 and angle 6 are also corresponding angles. And then we have angle 3 and angle 7, and angle 4 and angle 8. Those are all corresponding angles. So they have four pairs of corresponding angles. Okay, so the space that's between the lines is the interior. And so alternate interior angles are angles that are inside the two lines. And they are on opposite sides of the transversal. So that makes sense. Alternate, they're on the opposite sides. Interior, they're inside. And so the interior is between the two lines. The exterior would be outside of the line. So down here is the exterior, and up here is also exterior. And so alternate exterior angles are outside the two lines, but they're still on opposite sides of the transversal. So again, alternate meaning opposite sides, and exterior meaning outside. And the last type of special angle pairs we have is the consecutive interior angles. They are interior, so they are inside the two lines. But they're consecutive, which means they are on the same side of the transversal. So this time we've got consecutive, same side, interior. So looking at my figure, let's talk about what some of these are. Okay, so alternate interior angles, we said were inside the two lines on opposite sides of the transversal. So for instance, angle 3 and angle 6 are both inside but on opposite sides of the transversal. So angle 3 and angle 6 are alternate interior angles. Angle 4 and angle 5 are also alternate interior angles. Then looking at alternate exterior angles, I have to go on the outside here. 1 is on the left side of the transversal, 8 is on the right side, so those are alternate exterior angles. So angle 1 and angle 8. And angle 2 and angle 7 are also alternate exterior angles. And then finally, consecutive interior angles would be on the same side and on the interior. So 3 and 5 are on the same side on the interior, and 4 and 6 are on the same side in the interior. So angle 3 and 5 are consecutive interior angles, and angle 4 and angle 6 are consecutive interior angles. All right, so we want to be able to identify angle relationships, and sometimes they're going to give us figures where lines will be dual purpose. Depending on which angles you're looking at, they might be considered a transversal, but they could also just be a line. So you have to figure out which line is the transversal when you're talking about an angle pair. And the way you figure out which one is the transversal is the line that touches both angles. Okay, so the transversal is the line that touches both angles. So for example A, we're looking at angle 1 and angle 14. So sometimes it helps if you just cover up part of the figure that you're not using. So in this case, we're not even using this part of the figure over here. So I'm not even going to look at that. I'm just going to look at this portion right here that involves angle 1 and angle 14. Well, the transversal is line X because that's the one that's touching both angles. So line X would be my transversal. And I can see now that they are outside, so they're exterior, and they're on opposite sides, so they're alternate. So those are alternate exterior angles. All right, now let's look at the next one. Now I'm looking at angle 10 and 11. So the line that's touching both of them is B. So the transversal this time is line B. So I don't care about this part of the drawing up here. And so I see that they are on the same side, so those are consecutive, and they're inside, so consecutive interior. Next, we're going to look at 7 and 12. 7 and 12 are both touching line Y, so line Y is my transversal. And I don't care about this part of the drawing now. They are between the two lines, so they're inside or interior, and they're on opposite sides, so alternate, so those are alternate interior angles. And then finally, angle 5 and angle 7. I've got angle 5 and angle 7. So they are both touching line A. Line A is my transversal. And again, I don't care about this part of the drawing now, so I'll just cover that up or cross it out. And they're on the same side of the transversal, but they're also on the same side of their respective lines. So one's outside and one's inside, so they're not consecutive interior. So they are in corresponding positions, however, so they are corresponding angles. And that concludes the video. Thank you for watching.